This lesson will be on 11-2, rational expressions. The first part of the chapter explains what excluded values are. In a rational expression, an excluded value is any value for a variable that would result in a denominator of 0. Remember that when we have a fraction, we're not allowed to have 0 in the denominator, or we can't divide by 0. This would be this would give us an undefined answer or no solution. So if we have a rational expression like 4k over a, basically a cannot equal 0. Let's look at a few more examples of this. In example 1a of your book, we're given 5m plus 3 divided by m minus 6. In this rational expression, we're looking for the excluded values, or the value for m that would make our denominator 0. So what we'll do is we'll take our denominator of m minus 6 and we'll set it equal to 0. We want to figure out what value m would be in order to get 0. So if we solve this equation now by adding 6, we'll have m, that looks like a 0, we'll have m equals 6. So basically, if we have m equaling 6 on the bottom, or in our denominator, we'd have 6 minus 6, or a value of 0. And this cannot happen, so our excluded value is that m cannot equal 6. In example 1b, we're given x squared minus 5 divided by x squared minus 5x plus 6. In order to find our excluded values, we'll have to factor our rational expression. So in our numerator, we have x squared minus 5. That's not factorable. In our denominator, we have x squared minus 5x minus 6. This factors into two binomials. And we'll be looking at the factors of 6 that add to negative 5. Well, we have same signs, and they're both going to be negative. And the factors of 6 that add to 5 are 3 and 2. So x minus 3 times x minus 2 would give us x squared minus 5x plus 6. Now, we have to figure out the values of our denominator that would give us 0. So we set x minus 3 times x minus 2 equal to 0, and we solve this quadratic equation. So if x minus 3 equals 0, we'd add 3 to both sides, and we'd get x equals 3. If x minus 2 equals 0, we'd add 2 to both sides, and we'd get x equals 2. So our excluded values are that x cannot equal 3, and x cannot equal 2. In question 3, we're asked which expression is equivalent to a negative 3x squared times 4x to the 5th divided by 9x to the 6th. We can first start by multiplying our numerator to get a negative 12 x to the 7th over 9 x to the 6th. And then we could take our fraction and reduce this. 9 and 12 are both divisible by 3. And if we reduce our variables, cross off 6x's on the bottom and 6 on the top, we'd be left with negative 4x over 3. Now, through process of elimination, our answer is not A, because that's not negative. It's not B. C, our variable is on the bottom, so our answer is D. When the variable is out to the side of our fraction, it's the same as having it on top. So this is equivalent to a negative 4x over 3. In example 4, we'll be simplifying the expression 3x minus 15 over x squared minus 7x plus 10. We also need to state the excluded values for x. So in order to do this, we must first factor our numerator and denominator. 3x minus 15 factors by taking out a GCF of 3. So if you notice, 3 times x gives us 3x, and 3 times negative 5 gives us 15. In our denominator, x squared minus 7x plus 10, this quadratic will factor into two binomials. We'll be looking at the factors of 10 that add to a negative 7. And remember that we have same signs, and they're both going to be negative. So the factors of 10 that add to 7 are 5 and 2. We have this plus sign tells us we have the same sign, and the negative 7 tells us they're both negative. Now we must simplify our expression. If we have an x to the x minus 5 on the top and an x minus 5 on the bottom, we can reduce our fraction by crossing off both of our x minus 5. X minus 5 divided by x minus 5 will give us 1. So our expression simplified will be 3 over x minus 2. Remember that we still have to state our excluded values. So in order to state our excluded values, we'll be taking the expression in our denominator, the x squared minus 7x plus 10, and we'll be stating the values that would make this equal to 0. So in order to do this, we of course do have to factor it, and we already know what that is factored. It's x minus 5 times x minus 2. And now we'll be solving. If we set x minus 5 equal to 0, and we add 5 to both sides, we'd have x equals 5. If we set x minus 2 equal to 0, and we solve this by adding 2 to both sides, we'd have x equals 2. Therefore, in this quadratic equation, if x equals 5 or if x equals 2, we would get 0 in our denominator, so our excluded values are that x cannot equal 5 and x cannot equal 2.